34. Okay. All right, so we're going to look at operations with functions. Right? Notation is a huge, huge part of this. Understanding the notation and you being able to write the notation correctly. So functions can be combined using addition, subtraction, multiplication, and division to create a new function. All right, so what's another word for addition that's not just another form of the word addition? Sum, okay? So addition is also the sum, okay? It's kind of what you might see in a word problem, right? What about subtraction? Difference. What about multiplication? Product. And division? Quotient. Okay, so, and obviously there's other words that can imply those things too, but we need to make sure that we associate those. Okay, so if I have two functions, f of x and g of x, and I want to add them or get the sum of them, this is one way to notate it. I can just say f plus g of x, but I can also say f of x plus g of x. You need to know that both exist. This is the one, this column is the word you're going to see and use more. So then f minus g of x is the same thing as f of x minus g of x. Bless you. Then this is f times g of x, and that's just a little dot there. We're going to see something tomorrow that looks very similar to that, but this is just like a little multiplication dot. So f of x times g of x. And then f over g of x is the same as f of x over g of x. And you can only have a quotient of two functions if they're actually both functions. If I had something like f of x over 3, okay, yeah, that's a quotient, but it's not a quotient of two functions because this is the same thing as 1/3 times f of x. Does that make sense? So they both have to be functions. All right, here we go. So let's talk about the domain. So even though I know you have added, subtracted, multiplied, and divided functions before, you have probably not talked about the domain, so we need to look at domain. The domain of the new function. So we take two, we put them together somehow, and we get a new function. It's the intersection of the combined functions. Okay, so let's think about what that means. Some people think of an intersection as like when you pass through something. That's not necessarily the case. Yes, if you have an intersection at a street like this, they pass through each other, but you could also have an intersection like this, right? The intersection is where they cross. It's what they have in common, right? Where all the little accidents happen and all the trash is, right? So that's the intersection. So the intersection of two things that we want to think of mathematically is what they have in common. Okay, so the intersection is what the two streets have in common. That's why it's called the intersection. So we'll look at how we find that in just a second. Then it says the domain is further restricted with the quotient function to exclude values in which g of x equals 0. So basically, once we find the combined domain, that works for addition, subtraction, and multiplication, but then we have to revisit it for division because there's some further restrictions. Okay? All right, so let's see what all that means. So we have two functions here, f of x and g of x. And it would be really helpful to know what their parent functions look like. Most of you do. Some of you from that test, it's a hot mess. You have no clue what these things look like, and no wonder nothing makes sense to you, and it will continue to not make sense to you. So this is a quadratic, looks like this. This is a linear, looks something like that, okay? All right, so I'm going to find each new function and state its domain. So I have f plus g of x. So this is the same thing as f of x plus g of x. Right. So then I'm going to take f of x, which is x squared plus x, plus g of x, which is 3x minus 1. Anytime you substitute in something with more than one term, you use parentheses. Okay, sometimes they matter a lot, sometimes they don't matter at all. But if you do it every time, you won't miss it when it actually matters. Okay. Plus, you don't want to end up in math jail. All right, so do these parentheses really do anything magical here, or do they just group things? They just group things. It's like if they weren't there, it wouldn't change anything. But again, we do that every time. So then we just combine our like terms. So this gives me x squared, and then x plus 3x is 4x minus 1. That is f plus g of x. And notice that it is easy. And notice how I labeled my answer too. It's not about getting the answer. It's not about looking at it and knowing what the answer is. It's about showing your process and actually labeling what you have. This isn't f of x, this isn't g of x, it's f plus g of x. Or f of x plus g of x, it doesn't matter how you do it. Okay, so let's talk domain. The domain of my parent function for this is negative infinity to infinity. Once I do transformations, whether I move it left, right, up or down, stretch it, reflect it, whatever, does my domain change? No, the range will, but the domain doesn't, and all we're concerned with is the domain here. So the domain is negative infinity to infinity. What about for a linear? No matter how I transform this thing, is my domain going to change? No. The only way it would change if it was a vertical line, but that's not. So domain is negative infinity to infinity. So to figure out where how this works, here's my number line, right? This domain is all real numbers. This domain is all real numbers. So what do they have in common? All real numbers, right? This intersection, because this one's the easiest, but it's what I think confuses people some, because how did they, they both include everything, so we include everything. It's just the way it works. So this domain is negative infinity to infinity. And again, once we have that, you know the domain for this one and this one. We're going to have to revisit the quotient when we get there. Okay? Make sense? All right, so now we'll do the next one. This is going to be equal to, so it's f minus g. So f is x squared plus x minus g of x, which is 3x minus 1. Are those first set of parentheses important? No. Is the second set? Yes, very much so. When I combine my like terms, I just get x squared. Then I have x minus 3x, which is minus 2x. And then minus a negative 1 is plus 1. That is f minus g of x. And I already have the domain. Okay. Any questions? All right, so now we're going to multiply f, which is x squared plus x, times g, which is 3x minus 1. Then I have to multiply those two together, which is however you do it, the box method, the whatever, it doesn't matter. I always, well, I think it's fine. I always use, oh my gosh, I keep moving this thing on. I'm writing too close to the side. There you go. I always use FOIL, right? Which is, no matter what your process is, you're doing the same thing. It's just a different way to call it, maybe a different order, but it stands for first, outside, inside, last. So I'm going to take the first two, multiply them together, and I get 3x cubed. The outside two together, and I get negative x squared. The inside two together, and I get a positive 3x squared. The last two together, and I get negative x. So when I combine that, I get 3x cubed plus 2x squared minus x. And that's equal to f times g of x. Okay. Why? Because algebra. All right, so now we are going to divide. So I have f over g of x. So f is x squared plus x over 3x minus 1. So can I cancel these x's out? 1000% no. If you have more than one term, you better not start just crossing things out because you are wrong. All right? Is it possible that we could still simplify this? It's definitely possible. But the way you would do that is to factor out any GCFs. In the numerator, I have a GCF of x. So I can factor out x. That leaves me with x plus 1 over 3x minus 1. Now can I cancel this x with this x? No, because I still have two terms down here. There's still two terms technically up right in there, but this is like one big thing where I could, if I could factor something out, and I can't, x plus 1 doesn't match 3x minus 1, so I can't simplify it any. So this is f over g of x. And I'm not leaving it like that because it has to be factored. We do need to try. So this form is okay too because you can't reduce it. But if you just stopped and it could be reduced, then you wouldn't have it reduced all the way. So, we good? All right, so now let's go back up here where it says the domain is further restricted with the quotient function, and that's what we're working with right here, to exclude values in which g of x equals 0. Okay, so I'm not real happy with the fact that I put g of x, because yes, on some of these it's g of x, but it's whatever the denominator is. Okay, it doesn't always have to be g of x. So just whatever your function is in the denominator. So in this case, it is g of x, so I need to come over here and say, okay, well, g of x cannot equal 0. Why do you think g of x can't be 0? What happens when you divide by 0? You get, what's your answer? Undefined. Exactly, it's undefined. It is absolutely not 0. 0 is a totally fine answer. The denominator being 0 is the problem because you get undefined. All right, so g of x can't equal 0. So this is my g of x. So I'm going to say, all right, then that means that 3x minus 1 cannot equal 0. Then I just solve it. It's still an equation. I just have a slash through my equal sign. So I get 3x equals 1. Does not equal 1, I'm sorry. Then that means that x cannot equal 1/3. So we went from all real numbers to we can't equal 1/3, which we could write that in interval notation, but I'm going to do a set builder notation, which makes it a little bit easier since we're just excluding one number. Looks like this. You put your little squiggly brackets, okay? Then you have an x. This means the set of all x's such that x cannot equal 1 or does not equal 1/3. That's your domain. That's like saying all real numbers except for 1/3. Okay. Any questions? All right. So let's look at example 2. I'm going to draw my little sketches here. Here's my quadratic. Here's my square root. Okay. So when I look at domains, my domain here, no matter what I do to it, because we've already decided that, it's negative infinity to infinity. If I move this one around, would my domain change? Yes. So I have to look to see, are there any transformations? No. So this does represent my domain, which is just going to go from 0 to infinity. We good with that? So let's talk about what this means. We've got a domain that's all real numbers, and then we have a domain that goes from 0 to infinity, bless you. Where do they overlap? 0 to infinity, right? Remember shading in number lines like that? Hopefully. All right, so that means that this is going to be my domain for these first three. Domain goes from 0 to infinity. My domain goes from 0 to infinity. My domain goes from 0 to infinity. Then we will revisit the other one once we get there. All right, so we're going to start off with f plus g of x. So this is equal to f is x squared plus 9 plus g of x, which is the square root of x. Can I actually combine any like terms there? Do they have the same exponent on them? No. What does this represent? What exponent does this represent? 1/2. Okay, so this is like x squared and x to the 1/2. So just like I can't add x squared and x to the third, I can't add those. Okay, but so I can't actually combine anything, but I should put it in the correct order, which is descending order of my exponent. So this should be x squared plus the square root of x plus 9, and that is equal to f plus g of x. And then we already have the domain. What questions you got? Yes, you should always put them in the right order. Okay, anything else? All right, so now I have f minus g of x. So that's equal to x squared plus 9 minus the square root of x. So it's almost identical to this one, right? So this just gives me x squared minus the square root of x plus 9 equals f minus g of x. All right. So f times g, so my f is going to be x squared plus 9 times g, which is the square root of x. So what am I going to need to do here? Distribute. So x squared times the square root of x is x squared times the square root of x plus 9 times the square root of x. That is f times g of x. Then f over g of x is going to give me x squared plus 9 over the square root of x. Are you allowed to keep a square root in the denominator? No. That is totally illegal. So we have to rationalize the denominator. So multiply by the square root of x over the square root of x. And when I put this in here, I didn't put parentheses around it, but see, I should have because it matters, right? So when I multiply fractions, I just multiply straight across. It makes it super easy. So this just gives me the square root of x times x squared plus 9. I don't necessarily have to distribute here. Over what? Well, actually, let's distribute. We're going to do that. So you know how to distribute. So this is going to give me x squared times the square root of x plus 9 times the square root of x, which is the same thing we had here. And in the denominator, I just get x. And that is f over g of x. So then we need to go back and revisit the domain because we have the quotient. So I have to come over here and say whatever's in the denominator, which does happen to be g of x again, g of x cannot equal 0. So the square root of x cannot equal 0. So I'd square both sides and get that x cannot equal 0. So I use the same domain that I've had, but this is a further restriction. So the only thing that changes on my domain is that I'm not including 0 anymore. That's my domain. What questions do you have? We good? Ask me a question. All right. So let's look at number 3. So here's what these look like. What would my domain be on this first one? All real numbers. So negative infinity to infinity. And then here, same thing, negative infinity to infinity. So that means the domains for the first 3 are just negative infinity to infinity for all 3 of these. And we're going to skip A and B just because we don't need to do every single one of these. We're going to start with C. So I have f times g of x. F is 2x cubed times g of x, which is x squared minus 4x. Then I distribute. 2x cubed times x squared is 2x to the what? 5th. Then 2x cubed times negative 4x is negative 8x to the 4th. And that is f times g of x. We good? Okay. Now we're dividing f over g of x. So this is 2x cubed over x squared minus 4x. Can I cancel anything out at this step? No, because I have more than one term and I have nothing factored out. There's nothing I can do right now. But I can factor out a GCF in the denominator. So I have 2x cubed over x times x minus 4. Now I can reduce, because now I have like one big term down here and one term up here, and this x can cancel out with one of those. So that leaves me with 2x squared over x minus 4, and that equals f over g of x. Okay, so by looking at what we have here, what would you say that x can't equal? Positive 4. Okay, so let's go over here and see what happens. So we divided by g of x. So I'm saying g of x cannot equal 0. G of x is x squared minus 4x, and that cannot equal 0. So to solve this, I factor out the x. That leaves me with x minus 4 cannot equal 0. So what this tells me is that x cannot equal 0 and x cannot equal 4. Notice if I had just looked at my final answer, I wouldn't have gotten the whole thing, because we divided by g of x, then we simplified. But whatever you start with, that is your actual function that you're using, and then we simplified it some. So my domain restrictions here, it's going to be the set of all x's such that x cannot equal 0 or 4. That's my domain. What questions do you have? All right. On number 4, I do not expect you to know what these graphs look like. Well, you should. They shouldn't be brand new, but we haven't talked about them yet. So it's okay. We're not going to go by the way they look. We're going to go by what we know about the denominators. Would you say that the domains of either one of these is going to be all real numbers? No. What do you know for sure in this one that x cannot equal? For this one? 0. So my domain is just that x can't equal 0, because I can't have 0 in the denominator. So for this one, the domain, x can't equal what? -2. So for the first 3, I have the domain is a set of all x's such that x cannot equal -2 or 0. And that's going to be the domain for these first 3. Then again, we'll revisit the quotient when we get there. Okay, so f plus g of x. This gives me f of x, which is 1 over x plus 2 over x plus 2. So I'm adding fractions. Is changing it to a decimal going to help me here? Nope. Is the calculator going to help me here? Nope. You got to know your fraction rules. Okay? So we need a common denominator. To get a common denominator here, I'm just going to multiply the two denominators together, so I get x times x plus 2. That means that this fraction had to get multiplied by x plus 2 over x plus 2, so this 1 becomes x plus 2. And then this fraction had to get multiplied by x over x, so I add to that 2x. So that gives me, in the numerator, that's going to give me 3x plus 2 over x times x plus 2. I don't necessarily have to distribute that. Is there anything I can reduce here? Can I cancel these x's out here? No, 100% no. You've got 2 terms up here. That is 1,000% illegal. So there's nothing you can do. This is f plus g of x. All right, so on B, we're going to subtract. It's g of x minus f of x. So this is going to give me 2 over x plus 2 minus 1 over x. I don't get to just subtract the denominators and get 2 over 2 or something weird like that. I have to get a common denominator, which again is going to be x times x plus 2, which means that this fraction had to get multiplied by x over x, so this becomes 2x, and minus this fraction had to become x, or I had to multiply by x plus 2 over x plus 2, so this becomes x plus 2. Notice that those parentheses are super duper important. So then this is going to give me, so 2x minus x is x, and then minus 2 over x times x plus 2. Can I cancel this x with this x? No. Can I cancel the x minus 2 with x plus 2? No. I mean, they're kind of close, but no. Okay, so this is equal to g minus f of x. Okay. What questions you got? All right, so then we're going to multiply g times f. G is 2 over x plus 2 times f, which is 1 over x. Now, multiplying fractions is way easier than adding or subtracting fractions because you just multiply straight across. And when I multiply straight across, I'm going to get 2 over x times x plus 2, and that's equal to g times f of x. Then I'm going to divide. So I have f over g. So this is 1 over x over 2 over x plus 2. You cannot be afraid of fractions in fractions because it's going to happen a lot. You just have to know what it means. This is the same thing as 1 over x divided by 2 over x plus 2. That's what we're saying. That's what fractions are. So when you're dividing fractions, what's your rule? Keep, change, flip. Exactly. So I'm going to keep the 1 over x as 1 over x. I changed division to multiplication. I flip the second fraction. So then I just multiply straight across, and I get x plus 2 over 2x. Can I cancel these 2's? No. Can I cancel the x's? No. This is it. This is f over g of x. Then I need to revisit the domain. Okay, so go back up here. All right. So the denominator here was g. So g of x cannot equal 0. So 2 over x plus 2 cannot equal 0. Right? Everybody understand why I'm doing that, where it's coming from? Okay. So I want to get rid of this fraction. So I'm going to multiply both sides by x plus 2. When I do that, I get 2 cannot equal 0. Well, I 100% agree with that, but that looks way different than the other answers I'd gotten, right? So the reason I'm getting this, and that's a true statement, 2 can't equal 0. I agree. But I'm getting this and not like x can't equal 2 or something like that, because this is what this is telling me is g of x is never going to equal 0. Okay? It's never going to equal 0, so it doesn't matter. So that means that I don't change my domain. My domain is just the same as it was before. So x, set of all x is such that x cannot equal -2 or 0. So there's just not an additional restriction on that one. I shouldn't have boxed it because I just wrote through stuff. All right, so if you get something weird like this, but it's a true statement, it's like, all right, well, there's no further restriction. We good? What questions do you have? All right, so let's look at number 5. So in number 5, we know that our parent function looks like this, right? But I need to here, because when I transform that, my domain can change, and it does change on these. So it's really helpful if not only do you know what that looks like, but you know what the transformation looks like. So what's happening with this transformation? Left 6. So it looks something like that. Notice I'm not making hash marks. I don't care if it's exact, but it's over there like that, right? And I can just say, oh, look, that's 6. And then what's happening here? To the right, 2. So, oh, look, that's 2. Okay, just to have, because I got to think about my domain. So my domain here is going to be from 6 to infinity, and my domain here is going to be from 2 to infinity, right? So, -6, dang it, -6, -6. I think I heard somebody whisper that. Could have yelled at me. I'm sorry, what? I'm sorry, start over. I didn't hear what you said. Yes, so when I combine those, what they have in common is 2 to infinity. If you're not sure about that, or you're not sure how you got that, then you can literally make yourself a number line, right? We're here at -6, so I'm going from -6 to infinity. And then I'm here at 2, and I'm going from 2 to infinity. And where they overlap is what they have in common, so that's my common domain. Yes, very good. So I'm going to write that for all of them, or all three of the first three, rather. 2 to infinity, 2 to infinity, and 2 to infinity. I should have said this, Daisy, but if there's any that just don't work at all, like no matter what you do, just put them and make like a box or something for me. You put, okay, thank you. All right. So we're doing g plus f of x, or did I want to? No, we're going to do these. So g plus f of x. So g of x is the square root of x minus 2 plus f of x, which is the square root of x plus 6. All right? So I know some of you are thinking, great, square roots, it looks way confusing, and this is going to be hard. This is one of the easiest ones because I literally can't do anything else. This is my answer. Sometimes it's better when it's crazier because there's less you can do. So this is g plus f of x. So guess what else is going to be super easy? Subtraction. All right, this is going to be equal to f, which is the square root of x plus 6, minus g, which is the square root of x minus 2. There's nothing else you can do. That is f minus g of x. You can't combine. They're each in their own little houses, and adding and subtracting, they don't mingle at all. Okay. All right, so then we're going to multiply. I got g, which is the square root of x minus 2. I made that crazy big. Square root of x minus 2 times f, which is the square root of x plus 6. So when you multiply them, they do get to commingle. So I have to think of this as being parentheses, and then I have to legally multiply them. So I multiply the first two together, and I get x squared. Multiply the outside 2 together and get 6x, the inside 2 and get negative 2x, so that gives me 4x, and then minus 12. Will this square root knock out this square? No. Will it magically make this 4 a 2? No. If you have more than one term, you do not get to just distribute your square root. That makes absolutely no sense, and you cannot do anything else right here. This is g times f of x. Okay, we good? Then I have f over g of x. So this is the square root of x plus 6 over the square root of x minus 2. Am I allowed to leave a square root in the denominator? No, so I have to rationalize it. It's not any more difficult just because it looks more difficult. Square root of x minus 2 over the square root of x minus 2. So in the numerator, I have to multiply these two. I just did that right here, so I know what it is. So this is the square root of x squared plus 4x minus 12 in the numerator. What's the square root of x minus 2 times the square root of x minus 2? X minus 2. Look over there on that board. You see the second row of my monkeys? The square root of a monkey times the square root of a monkey is a monkey. It does not matter what's underneath it. If you multiply two identical square roots, you get whatever's underneath it. So this is just x minus 2. And that is f over g of x. Under the square root, yeah. So we have this, okay? So I have to revisit my domain. the denominator, which is g of x, cannot equal 0. So the square root of x minus 2 cannot equal 0. Square both sides, x minus 2 cannot equal 0, so x cannot equal 2. So the further restriction I have here is just that I don't include 2. The domain is going to go from 2 to infinity. It's just not inclusive. Okay. What questions you got? All right. So now we're going to evaluate, right? When you do the evaluation, we don't care about the domain and stuff. We're just going to substitute stuff in. So it's f plus g of 5. So that's the same thing as f of 5 plus g of 5. And you should totally be able to evaluate those. So f of 5, this is going to give me 4 minus 5 squared plus g of 5, which is 2 times 5 plus 8. And I just substituted it in when I added them. So 5 squared is 25, so I get 4 minus 25, which is going to be a negative 21, plus 10 plus 8 is 18. So f plus g of 5 is equal to what? Negative 3. Everybody understand where all that came from? All right, so now I'm going to multiply. So again, this is the same thing as just multiplying the 2. So I'm going to do f of negative 2. So that's 4 minus negative 2 squared times g of negative 2. That's 2 times negative 2 plus 8. So you go ahead and simplify that one, then we'll talk about it. What's negative 2 squared? 4. So this becomes a positive 4. Then I make it negative. So I get 4 minus 4. What's that? 0. So once I get 0, does it even matter what's in the next set of parentheses? Nope. So f times g of negative 2 is equal to 0. I mean, you could find it if you want. You just don't need to. All right, what questions do you have? We good? All right, so you have a Delta Math assignment. Don't procrastinate on it. You have time left now to fold this and tape it into your ISN on page 34. Make that happen too.